if you are refreshed, let's do some more activities now, right? Now this is a bit more intense activity than the think, pair, share and all those things we were doing. Now you will wear your teacher's hat and design something, right? So what you are going to do is design an active learning based activities for a session to introduce data types that can be used for supervised learning. So we know what supervised learning is, yes? You give data is labeled and the machine learns based on that. So basically the learning objective will be the learners should be able to recognize various data types and determine the required data to solve a given problem using supervised learning. That is the learning objective, right? Class duration is 30 minutes, deliverable at least one activity and what the timeline should be. So I'm assuming you all know, like when we create a lesson plan, we have like what is the duration, what is the kind of activity, what the teacher is doing and what the student is doing. So basically you have to create that table, right? And we'll take some 20 minutes I'll give you guys 20 minutes to design activities, right? And before we do that, I'll just briefly cover what are the different data types. So you have qualitative data and you have quantitative data, right? What are some examples of qualitative? So qualitative data is something that it cannot be quantized, but you can always have you can have a representative for that, right? So smell, taste, texture, attractiveness, color, all these things. You can't, there is no quantitative measure for it, but you can always associate something for it, right? But other things are numbers, dimensions, temperature, price, area, volume, right? So we have symbols, words, numbers, image as data. You know how image as data is represented. Each pixel gets a value and that is the value matrix, and basically that's how an image is represented, right? This is a grayscale image. For a colored image you will have three matrices, R, one for red, one for green, one for blue. Then audio data is again amplitudes, frequencies, again in numbers. And what do we do in machine learning is we have some data that we input, we do some labeling in case of supervised learning. Cleaning means when we have a data there might be some erroneous data, so basically you remove that. Structuring, interpretation, analysis, I mean we can ignore that part for the activity. And just an example is like how does an autonomous vehicle work. So it has, what are the different kind of data it is getting. There is a long range, which is basically some sensor which is capturing how much the distance is clear, there is no object. There is a camera somewhere which is capturing the images, and then there is another algorithm which is analyzing these images. Now not just one camera, there are a number of cameras, one camera for what is happening at the back of the vehicle, on the sides of the vehicle. Then you have another short range sensor which is basically measuring, say, just the next 1 meter of the road. If the road is clear, does it have any pothole or something like that. Then there is something called a LiDAR. So basically you can think of it like a camera, but what happens is it works like a radar. So there is a laser that keeps rotating and there are receivers that receive that laser and they are trying to create a 3D map of what it is. So I mean for the activity just take it as like what are the different type of data that you get that are required for making an autonomous car. That's an example, right? So take some time, think of ways you can actually design one activity, at least one activity for a session, and make a lesson plan, right? So your lesson plan, what all should it have? Your duration, which is total is 30 minutes. What is that you are trying to focus in that particular segment? What in that particular, say the first 5 minutes, you are going to do an introduction. What will the teacher do? During that introduction, will you give an activity for them to experience something, or in the first 5 minutes, you will talk about data types and what will the students do, right? So just create that table and let's see. I've given 20 minutes. If we are able to do it quickly, we'll just move to the next one. Hope I'm clear. Any doubts, you can just raise your hand, ask me, call me. Yeah. Yeah, you can. So basically the idea is that your student should know there are various data types, and you can take an example and say, in this example, which data type will work. Multiple data types will work. Like I gave you an example of autonomous car. I mean, you are free to go online, search for things, and then, but if you are using ChatGPT to create your lesson plan, at least put in your ideas also. So you can work as groups. Data types for AI. Basically, you will take an example of some AI based function like I showed you smart cars. So what are the different data types? You can take that example and then introduce them. Okay, these are the different data types that is required. So that is what you have to teach. Any confusions? Yeah.
Design for something specific, or it's like a general list idea?
So, I mean, it's your call actually. So, the idea is that you have to make them aware that there are different data types, and for different applications, different type of data is required. So, you could take an example and start with that and then get them to data types, or you could start with data types and then get to the example. So, I mean, that is the creative freedom that you have, right? But what you have to ensure is there has to be one active learning strategy involved here. Yeah. So one thing that is mandatory is this: you have to have one activity, active learning, any activity, at least one. You can have as many you want, but yeah. Any confusions? Any confusion or anything? Yeah, you can pick that. You can pick that. You can pick a problem and then based on that you can actually, yes. Like the example I gave was for autonomous cars. You can take any. So you guys have chosen a example? Okay. Good, good. You have a, huh?
Sir, our system is like this, sir.
Hmm.
We have smart vans installed at various locations
Okay.
in the city.
Okay.
Now, the system is when the van is 3/4 filled, it will give an alert to the collection center.
Hmm.
Alright. So now the data that we are looking out for is basically the content in the bins.
Yes. Yes. How do you do that?
Yeah. Yes.
First, we need to sort the.
So there is dry waste and wet waste.
That is already being sorted done.
Look at it. Description is over. You have to identify.
So but now you have to identify the data type, right? Yeah, data type. So basically, what would you use if you had to identify? So what are you looking at? You are looking at a bin, which is either full or so
It's basically
depth. Basically, yes, depth. So yeah, there are sensors that can do that.
there are sensors which can do that.
Yes.
We are just identifying that type of data.
So have you worked with any of the sensors? Yes, it will be a number, right? So yeah, that is your data type for the example.
So both the data types should be numbers.
Yes. Okay. Yes.
That is again a distance.
Yes, but how does that system get to know the distance is what you have to think about. So I can tell you like 4 or 5 ways. So you can have satellite imagery, which is image data type. Then you can have data from Google coming in, that is again could be text, could be numbers, could be images. I mean, there could be API which is talking to the Google Maps and getting the real-time traffic data. So you can have images, you can have numbers, whatnot.
Second data type could be images or numbers.
Yes. Yes. So yeah, this way you can think of different ways of.
If we investigate, we'll find more data.
Yes. So
And again, the refinement to that.
that's fine. So the idea is that you have to introduce them to data types, right? So if your problem can be solved in number of ways, that is fine. You can actually give that as an example that this is one way you can take, that is one way you can take, and probably now design an activity around it.
Basically, we are introducing a problem to them and we are trying to identify the data into them.
Yes. So they will try to identify the data, and that's how you will introduce them with the. That works. Done. Keep it. We all will discuss it together. Okay. So one group is done. Any other groups who are done? Almost there. You are done with the activity design? I mean, are you done with this timeline basically? Your lesson plan. So basically the lesson plan is like duration, what you will do, first 3 minutes, what is it that you are doing, what the teacher is doing and what the student is doing. So like first minute, introduction, teacher is talking, students are listening. Okay, I'll take a look at it. Yeah, so it is.
First, we are starting with the introductory video on multimedia.
Okay.
On that, students are asked to observe different types of data representations.
Okay.
So later on, they are going to discuss with their partners to figure out what all data types they have observed.
Okay.
Then review with the teachers based on the observation.
Okay.
Later on, show the images with respect to the data types.
Okay.
Ask the students to analyze and classify them according to the data types.
Okay.
And then conclusion.
Okay. Fine. So can you think of like putting it into a context? Context as in, so if you have an example where they can associate that data type. So again, you use a multimedia, right? So that is one. That is a good way of getting to start and starting a discussion actually. So any way where you can kind of incorporate a context, like I was giving a context of autonomous car. So now what we are trying to do is, they know these data types, but how do they get used? that is the next step, right? So can you think of a way where you can get to that step as well?
We have our mode of learning is only interactive actually. So
Okay.
then the students are actually coming out with their own small modularized presentations as
Okay.
a part of the syllabus.
Okay.
So in that respect, when they wanted to demonstrate something,
Yes.
a small topic wherein we call it as a micro learning activity.
Yes.
So that the students would be preparing a small content.
Yes.
So in that content, we can incorporate all these different types of data, such as maybe a numeric part of it would be the startup in terms of numeric and text. Then coming further, they will be having the images for the introductory part of it. Moving further, they would be maybe downloading some content of audio, realistic audio, available over the internet as pure content, and maybe they would perform an activity of editing operation, that is cut the part which they would require only for the subtopic which they would be interested in presenting. And coming further, maybe that
So all this is happening in class?
they would be doing it out. We would be informing them the tools and techniques which they would be
So-
using, and then they would be coming forward. It would be an activity of 5 to 10 minutes, and they normally have this session as an interactive mode of learning. During the course of time, maybe we have an extra lecture within a week or the next of the further days, and we get over with that. So they are actually integrating all these different types of data as a multimedia content on the title of subtopic allotted to each student. Assume that I'm having
Okay.
60 students.
So different students are working with different types of data, right? And they are doing these micro sessions where they are doing certain present.
Maybe that there would also be a content which is designed by one student integrating all the different types
Okay,
of data.
fine. So what I am trying to see is why is there a division between the out-class and in-class activity?
We can only because net connectivity, maybe that our college is actually located at an area wherein telecasting or having an internet connectivity during the session, because we have a strength of 60 students sitting in front of us, making it available is not so feasible. So
Yes.
if it's a small
So
class, where during the lab
that's
sessions
fine.
we are doing it.
That's fine. So not talking about that issue. So, but can you create a context
Yeah, of
for
course,
that?
all these are the subtopics given to each and every student as a context.
But again, you are again choosing the topics for them, right?
No.
Here.
For example, I'm having a sub-chapter as
Uh-huh.
cybercrime. So there would be somewhere around 20 or 25 crimes which have been identified
Okay.
as the extended part of that syllabi content allotted by the university.
Okay.
So these are given to the students. One among them would be choosing, a group of students would be choosing one subtopic. For example, they would be choosing malware.
Yeah,
So
okay.
within that, there would be classifications as types of malware.
Yes.
So that group member each would be opting one type of it, that finish off. Then moving to the next student, they will take up some other activity as social engineering attack. Next will be coming out
Okay.
with
So now what do the students do in class?
in class, they would be coming only for the demonstration part of it. The activity of designing it, maybe having a group discussion among themselves and making it as a sequential pattern
Okay.
will be all done outdoor activity.
Outdoor activity. Fine. So, but what you see here is each student is individually working with their own topic.
Yeah.
Class, they are just presenting their
The
topics.
presentation is a collaborative learning approach wherein the student presents, every other student is given a provision to have an interaction and discussion after the completion of one group activity on a day.
Okay.
I can interfere, I can
Yes.
intervene.
So, how do you direct? How do you focus, or how do you direct the students to have that interaction? Like, if you just tell them that okay, have an interaction.
No, it's on behalf of me. For example, it is actually a syllabi sub-modularized content. May not be exactly fitting
Sorry.
into the syllabi. So the student is actually presenting it. I, along with my student members of the class, are given a chance for another 5 to 10 minutes to listen to them and come up with some queries which is having
But
a peer
what
learning
I'm
activity.
yeah, but you are saying peer learning activity. But what I'm trying to see is how does the entire class interact with that group, and how are the intergroup interactions happening?
It's happening only in the class. During the demonstration, there is a small part of the demonstration
But
day. where
exactly.
you are given 15 minutes.
But then how will you manage the entire timeline for it? This is becoming really extensive.
Yeah, 5 plus 5 plus 5. So, no, normally when it is a last lecture, for example, when I'm having a lecture from 1 to 2, nobody will be wanting to listen to the teacher. So, in that way, we make this activity wherein at least there is a good participation from the student
Okay.
side.
So what I'll say is so what you are talking is a possibility towards active learning. It is going there. But I mean, we can discuss it further, maybe offline, because
When it comes to an undergraduate level,
huh.
the way how you talk, maybe it's a little further having an active learning capacity to learn and understand instantly. These are the crowd of students to whom we need to give them some time to read it, understand it by themselves, come back.
I have exam, so I don't have it right now, but we have done these activities for a 500 student classroom strength,
Yeah, we can. It's not a hassle.
and it happens.
Yeah, it's not that I'm not saying.
No, I know. We are just having a discussion. Please don't feel that. So what I'm saying is probably we can continue the discussion maybe off class, because I'll have to now. So what you were saying, yeah, you are moving towards something which we are looking at an active learning strategy. But again, at the same point of time, we'll have to consider that there are a lot of instances of it.
Yeah, it is.
Instead of having one major activity in the end of the course, how can you how can you create it into the entire course, right? Yeah. Uh, I was clear about that. Okay, thank you.
Prediction of a heart disease or heart condition.
Okay.
So these are our inputs.
Okay.
Of a person, weight,
Yes.
blood group, and all the symptoms.
Yes.
So this is going to be our training
Training data. Yes.
Then predicting the output based on these data.
Okay.
So we give an input of the next patient who comes. If the patient has a heart condition, certain parameters have to be met. If those are meeting, that means that the patient has got a heart condition.
Yes. So basically, you will be taking these data, and basically out of a set of this, you will label that. Okay, if this is that is a heart condition, and it's not, right? Yes. So this works out way. Now, how do you use this and create a lesson plan, and what do the teachers do? What do the students do? You can now think of that. So this is a good example to go with. Now, these are different data types that you have. So how do you basically plan your class so that you do this activity using this concept and introduce data types, right?
Could you show that slide of that autonomous car?
Sure. Any other group? Huh.
So 30 minutes
Mhm.
lecture, 10 minutes will explain the concepts and all, we'll give them some examples, 15 minutes for activity, and last 5 minutes summary.
Okay.
So in this 15 minutes, we were thinking of giving them movie ticket booking system.
Okay.
And for this multiplex, we wanted to ask them this question to identify the various data types. Now here, I just wanted to ask you, is it okay if we like to assist them in knowing the type of data? Can I put a question like, for these subsystems in this ticket booking system, identify the data that will be required?
That is fine, yeah. Yeah, you can always ask. So that, that's a way of what we call Socratic questioning. So basically, you question them, you get the answers from them by questioning them.
Yeah, so and it also helps them to be a little bit more
Yes.
focused.
Yes. So one thing that I want to ask is, so how is the AI part being involved in the movie ticket booking system? Like we were looking at the supervised learning, right?
We didn't think of AI.
That's okay, no issues. But you got the.
Okay. But it is supervised learning, no?
Yeah. So you can actually create a AI system out of this. It could be like a recommender system.
Looking out states like which are the seats that are more sought after, so that can.
Yeah. Or it can be a recommender system. As soon as it sees you, it basically gives you recommendations. Then just the type of data will change. But yeah, this thing can work.
We are trying to have this under home
Okay.
automation, managing lights.
Yes.
So for that we are having light sensor and motion sensor unity, and data will be integer type, right?
Okay. Yes.
Now, what type of activities we can build over there?
So one is that can you think of more type of sensors that can be used for home automation? For example, if I am coming.
Temperature control.
Yes, but again, the temperature will also be the same data type.
Yes.
It's basically numeric data, right?
Yes.
So can you think of, say, if I am coming to the house should recognize that it's me.
Okay.
Yeah, that becomes a different data type now.
We were also thinking of giving a voice command
be to switch
Yes,
on
yes.
voice
So
recognition.
voice recognition, that basically it becomes numeric, but it starts with the voice, right?
So an activity then what are they supposed to do, right?
So once now you have your example in mind, right? So now you will use this example and then try to create a in-class activity. For example, so think of a home automation system. What are the different things? The home automation system does this. Now you think what are the things that is required? What are the sensors that are required? What are the so then from the sensors then you can come to okay, what are the data that types that it will give, and then you can come to okay, now if you have these data types and this is what is supervised learning, this is how you can your AI system can learn maybe my face, or maybe it can learn that at this point of time I want the sunlight or I want the lights to be on.
So first activity can for them to observe.
Observe.
Observe, identify,
Yes.
and then analyze what can be automated.
Yes. Yes. Okay.
So we have divided 30-minute session of lecture in so many parts as per the time. Okay. So in the beginning we are going to introduce about the data types which are required for automated car.
Okay.
Then later, in 7 minutes, we will give time for the student to perform the think per share activity, wherein they are going to recognize about this quantitative and qualitative.
Okay.
They are also going to understand by themselves and discuss and get to one.
Sorry,
list
you
of
said
data types.
discuss. So, what is the type of activity that happens?
They are going to discuss about
Think.
per share.
Okay.
Think individually first,
Hmm.
minutes,
Hmm.
then they think in pair.
Okay.
So they are going to here they are going to discuss and get which different data types which they are going to think what a car can have, automated car can have. So after that activity, in later 5 minutes we are going to teach again, and we are going to tell them which are the functions which are required.
Hmm.
Okay, which modules which are required, which are the functions of a car. We are going to tell them. And later half in think per share only they will discuss about they are going to map the data types we have already discussed with the
Functions.
functionalities what they are
Good.
what you have thought.
Yes.
After that, we are going to summarize the entire automated car designed by each of the groups.
Okay. And how do you do the summarization? How does this happen?
So they are going to come and tell about how they are designed, what are type of car, what are the how they are mapped. All they are going to summarize here individually in that 8 minutes.
Okay, but they come and tell. So how does it? So how does it summarize for the entire class?
Each group will be coming.
So you have
Then
like
you do a discussion of each one's presentation.
okay.
So the entire class comes to know what the others have discussed.
So basically, what was you saying? The
I was saying, so when a group comes, the entire class is listening to their presentation.
yes.
And even the teachers.
Huh.
So at the end of each presentation, there is a discussion as to what the others think about it and what the teachers
Okay.
think
Yeah.
about it.
Again, so yes. Now when you specify that, then it becomes okay. Then it becomes a summary.
So that is how we are covering on the
Yes. That's good. That's good. Okay. Any other group? Anyone else? Okay, so what we can do is, now I have seen a number of examples, but I don't want it to be limited to me. So all the groups that have finished and we have talked about, you can, I mean, someone from your group can just stand and talk about your lesson plan. Okay? Again, volunteer or be chosen. Yeah, please. So, can we have attention here? Yeah, please.
It's about home automation. So under that we have taken managing the lights, temperature, face recognition, and thumb impression to lock and unlock the doors.
Okay.
So data mostly will be sensor based, and it can be the form of integer, floating point data,
Okay.
and then there will be face images will be there,
Mm-hmm.
and there will be thumb impression, so that will be patterns.
Okay.
Then activity that we have designed for this is we can ask the students to think about their home and think what they want to automate and till what extent they want to automate. And for each of the things that they want to automate, we can ask them to find out how actually the things are working right now, how they want it to work, what are the different sensors which will be needed, and then think about the different scenarios which may be there when we want to automate, and how those scenarios are going to flow from one scenario to another scenario. And what are the data they will be needed, the sensor will be needing in order to automate it.
Okay, so basically mapping your sensors to what type of data does that sensor require. Okay. So how do you manage the time? So it's a good example and a good approach. So how are you managing the timeline of 30 minutes?
Sir, it is going to discussion will be on the topic. Like when we are saying think about your house and then what you must automate and till what extent you must automate. So basically, you can ask the students to think individually first, then discuss in a group of 3. So it is going to take around 15 minutes.
In that, and in the rest 15 minutes?
The remaining 15 minutes, they can think about, they can actually divide among themselves different things that they want to automate.
Okay.
And then either in a pair or individually, they can think about it. And then they can note down whatever information they have collected, and then they can share among themselves.
Okay, fair enough. So anybody, any questions or anything? I mean, others are also supposed to listen, right? So, yeah, next group.
So first we are going to discuss, the teacher is going to explain the different data types which are there and giving examples. So that will be for 10 minutes. Then the remaining 15 minutes is for the activity. So activity is like a problem is given to them. Say for example a movie ticket booking system. So the students are told to identify the different data types in that particular system. So they have to first think individually, write it down, then discuss it with the other members in the group, and then shortlist. So that will be for individuals in these 5 minutes, for discussion in the group 5 minutes, and then for summarizing for all the groups again another 5 minutes. So total 15 minutes activity. And then the last 5 minutes will be for the teacher to summarize whatever was done in the activity.
Okay, thank you. Any questions? I mean, you have to ask questions, right? There are questions in your mind, I know. Okay. Any other group? Any other group? Okay, any groups that have found some similarity in their lesson plans to the two that were, what is the similarity?
So we introduce data types first, then we explain about we take one real life example, like for example a smart refrigerator and what are the data types associated with it, like for example eating cooling habits, then if the food is low, whether to order new food or just tell the owner what to do. And then even activity wherein students should discuss or think about one example and all the data types related to the example, then discuss with the peers. And after the activity is done, we can have a discussion on what are the different data types we have learned and then summarize the entire session.
Okay. Anybody else? Same. Okay. Summarization. So basically the summarization, the important part is that you have to enable reflection into students. They will have to think of what did you do in the last 30 minutes. Right. So your activity in a way has to happen in some way that they, go like we did. We were doing introduction to AI, then we stepped back and we try to look at how we are learning AI. So that is one step they'll have to do. Okay, this is what we did in the class, but why did we do this? So get that going, right? I mean, again, the activities are fine, but that is what the focus of the last summarization activities, right? Okay, so it's 12:15. Okay, I was planning to talk about this is again getting into the context of how machine learning happens. There are a lot of models. This is one of the models. Then there are different type of algorithms that you have. Now I have another activity, but first let's go through it and then we'll decide whether to do this activity or not, because I also want to take the ethics part of it, which is another important and interesting part, right? So you have something called classification algorithms, which basically classify based on certain parameters. There are a number of algorithms that are written there. You have regression algorithms, and all of them are under supervised learning. They can do for categorical data for classification. If you have numerical data, you can use regression, right? Clustering is one way where based on certain patterns you create some clusters. Association rule learning. Any idea what is this? Yeah. Any idea where it happens very frequently? Yes. Fine. Then we have something called dimensionality reduction. So this is basically you basically take certain parameter and then you try to see how many groups can you create. But again, if based on parameter, you will have different subspaces that you will be able to create, right? There are a number of algorithms that can be used to do that, and all of these lie under unsupervised learning, exploration of data, finding relationship, extracting variables. So any of those can be used. Again, you know about neural nets? So it's basically modeled on the neuron, right? I mean, the reason I'm just going ahead is because I'm assuming this is all information and this is available there. So the idea of having this is, having this was to do an activity, but probably we won't do that. Some examples, yeah. So some very basic examples that can be done maybe in that can be shown maybe in a entire session, or session I mean the entire semester, right? So there is this concept called ALVIN, which is called autonomous land vehicles in neural networks. So I mean, this is during when I was studying soft computing. So I had tried this out. So basically what this is, if the video plays, there is this car. This has a Raspberry Pi mounted on it and a camera. And there is a simple neural net kind of, basically I guess it's a perceptron which is running on it. Already available code. So what it is doing is, it has a webcam. What I have done is I have driven the car. So whenever the car sees one image, I tell it, now you have to go straight. If then it gets the next image, I tell it, you go straight. For 100 images, I trained it. Then I left it to see what happens. So this car is supposed to stop at the black line. Now it has come to the edge, so it is taking some time to decide or not. And that one is trying to navigate. So again, setting up this one, setting it up can take around a day or two, but it is interesting for the students. But yeah, there are certain resources that are required. Like there is a Raspberry Pi. They can create their own vehicles. I used a toy vehicle. They can create any robotic vehicle and do such a kind of an activity. This is a very extensive project that people have done. They have used OpenCV. So what you see here is, this is what is being fed to the neural network, right? That image that you were seeing there, this one, and this image is basically labeled as you should go straight or take a right or take a left. So every image is like one data for your training part. Now there is also image recognition built into it. So these are some small examples that I am showing you, which are possible like for a semester long experiment. So if students try this out, they will have a very good understanding of what actually happens. So this is what I was talking about. So that one image that you were seeing, that small image, so every pixel becomes one node of the network. So if you have a resolution of say 320 into 120, you will have 38400 nodes in the beginning, and then you can have inner layers, and then basically at the end you will have 4 nodes which will decide whether based on this image you should go left, right, forward or reverse. Okay, very simple way of building something. Here they also get to build some physical object, and then you can connect it to how the current generation of autonomous vehicles work, because these vehicles, they don't just have a camera, they have number of cameras and a number of sensors like we talked about, and then that working on that can be associated to how things are happening actually. So some more examples. So I'll just talk about this reinforcement learning. I told you this is the way people trained algorithms to play games. Now this is a good starter for the discussion on ethics. Why? So they created the first algorithm called Go. Okay, Go is a game, right? So for this algorithm, they gave human data, domain knowledge and rules, and AlphaGo was able to play the game better than the champions of that game. So AlphaGo 0, they just gave it the rules, and through reinforcement learning, it learned to play the game, again defeating the world champions. Alpha 0 was given the rules of Go and then also left to play with chess and this game. It learned these as well. Now when the algorithm had matured this much, they created a new algorithm called Mu0. They didn't even give it rules. It learned Go, chess, this, and also learned Atari, which is again a console based game. So this is how advanced the algorithms have become, just through reinforcement learning. They are able to figure out the rules also themselves and then figure out, okay, this is what they are supposed to do. So just some examples. You can read more about them called DeepMind in a place called DeepMind. Okay, fine. So I'll skip that activity and let's talk about the ethics part of AI, right? How many of you feel it is a very important topic that should be talked about, ethics? It is, right? Okay, so let's think about this scenario. Understood this scenario? Yes? So you are going to design a system, AI system. So who are the stakeholders here based on the scenario? Students, parents, school administrators, doctors, nutritionists, right? So what do they care about the algorithm? Students probably taste of food, parents taste, nutrition, price, all three of that. School administration, nutrition and price, doctors only nutrition, right? So now the question is, what do you optimize the algorithm for? But if you are the person who owns the school, what will you do? Or if you are a doctor? So again, there is no correct answer for it. But what we see is that there are various ways you can optimize the algorithm and it will work differently then, right? So this is a question this is a thought that we'll have to have when we are thinking of, say, designing an algorithm based on AI. Okay? Let's do an exercise, a similar exercise, right? But now we'll put YouTube on the spot. Okay, what we'll do is, we'll look at different features of YouTube right? We'll try to see what data it is collecting. From that data, what is YouTube learning and what is it doing with that learning, right? So it's something like this, like you have different stakeholders, now you have YouTube ka different features. Now they are collecting data and trying to do something, right? And what are they doing it for? Okay, so first 5 minutes it's a individual activity. Features of YouTube, they are like what? Sorry? Play a video, and search is one of the features of YouTube. Ads is one of the features of YouTube. Recommendations is one. Comments is one. So you have playlists. So you have these many features. Now for each feature, try to think of what kind of data they are collecting. Then try to think of what are they learning with it, and yeah, what is it doing with that learning. I believe most of us are already in the pair phase. Yeah, fine, go ahead. How many features do you have? 7 features. Okay. So you know what the data they are collecting, what they are learning from that data, and what they are using it for. Okay, different groups, how many features do you have? How many features do you have? 6. You? 7. How many features? Groups. Let's get back. And time to share. So each group share one feature, data, what is it learning, what is it doing with it. Audio, video, okay. What is the data that they are taking? Played, and how long? Anything else? Yes.
And then after how much time we continue.
Okay.
Pattern of whether we skip while.
Yes. Whether is it skipped? Okay. So what is it learning with it? Yes. Preferences of a user, right? Yes. And probably your type of user can be what they are doing with that preferences, right? Anybody, any other answer for this feature? Same? Okay. Next feature. Search feature. Okay. Okay. So even that when we were talking about, so they were classifying users based on what they prefer to search. So kind of preference, right? Okay. Other feature. Like button. Yeah, go ahead.
Like button, data is like whether you like or dislike. What it is learning is the preferences again, what kind of videos the user likes or dislike. Accordingly, what it is going to do is it's going to recommend the next video.
So yeah, so we are getting that they are doing a lot of recommendation of the next video, right? Fine. Let's look at another feature. Kind of a recommender system, right? Okay. Anything else? Any other group has some subscription? Yeah. What do they do with the what do they record? Okay. Okay. Again, it comes to recommendation. Playlist, yeah. Wish lists. So okay. So yes. So most of us said that they are doing recommend. Anything else? So recommender system is kind of what they are getting to. But what are they doing with the recommender system? What is happening? What is basically their stakeholder and what are they optimizing for? advertisements.
Saves time.
So if it saves times and gives you more recommendation, what will happen? So basically it is keep the user in the system, right? So the better you recommend, the more you will keep the user in the system, right? Now let's see what I came up with. So basically one was suggest search, you guys said autofill. Previous search history, what they are using, what are the most common searches, so that it can predict what you want to see. So you watch more videos, right? Then recommendations, so that you watch videos. So basically it is looking at videos clicked and therefore more ads are seen. The more you watch videos, the more ads you see. Again, now this is the perspective of the stakeholder of YouTube, which is earning, right? Comment section, which comments will keep the user on the platform longer, right? So what is the perspective that we have of comments versus the stakeholder? What is the perspective or what is the goal of comments that they have? We think comments as initiating discussion, right? But what we see here is YouTube is optimizing the comments for keeping the, right? And again, search results again goes to videos. Again, ads, the more ads they put, the more ad conversions they can get, and the more relevant ads they give you, there is a higher chance you might click on that ad, probably buy something, right? And videos watch, why? To keep users on the website. That's what we talked about, right? Now, why is this important? This ethics matrix, why do you think it is important? Like we just discussed, like we think comments are for discussion, whereas their perspective is comments, if you have relevant comments, more comments which keep users on and keep users, make users keep commenting, the people will stay on the system. So any thoughts on what does this ethics matrix actually make you do? Like when we did the YouTube ka ethics matrix, what is it that we have kind of realized? Yeah, I mean, yes. So with that realization that how to keep the user on the platform, what is the thing that we are getting to? Like for in the school example, we had 4-5 stakeholders. Now we were thinking of whom should the algorithm optimize for. Now again for YouTube, who are the stakeholders? We are the stakeholders, the company is the stakeholders, the people who advertise on YouTube are the stakeholders, right? So what is the algorithm optimizing for? More views. So is that what we want, or is that what some other stakeholder wants, right? So basically ethics matrix can get you thinking about who are the different stakeholders, what is involved, and whether what you are doing is ethical at some point of time or not. Like there is a lot of conversation around YouTube, Facebook, Instagram that they keep users on the platform and number of hours go away and people are not able to realize it, right? I mean, this has happened through decades of research. I mean, it's not just they tried something and it happened. But again, if the stakeholder is, say, person who is concerned about mental health, would that stakeholder want such a system? So basically, with the ethics matrix, you are able to find the different stakeholders, then try to see what are you optimizing the algorithm for and how different stakeholders are going to be affected by it. And then you can have the discussion on whether your optimization is it ethical, right? So am I able to convey the point of and the reason of the ethics matrix? Okay. This is just one way of doing it. So when we talk of ethics in AI, basically we talk of these 4 things, which is fairness, robustness, explainability, and privacy. Fairness is a lack of, okay, go ahead. Fairness is about, is the algorithm fair to everyone? But who is it that is training these algorithms? It is us, the data that we provide, and we know humans have biases. So it is very obvious that your systems will also have those biases. Example. So this was in US. So they took a lot of criminal data, right? And then they trained the system to identify basically all the convicts. They wanted to give them a risk scale, right? Now, when they tried out this algorithm, they were like shocked by the kind of results that they got. So this person, I don't know if you can see it from there, has been, his previous offenses are 2 armed robberies, attempt of armed robbery and 1 grand theft. And his prior offenses are 2 juvenile misconducts, okay. Subsequent no offenses. This person was given a low risk, this person was given a high risk, right. Again, this one, prior offenses, domestic violence, grand theft, petty theft, drug trafficking. Here, petty theft, no subsequent offenses. The risk rating is 3, risk rating is 6. So we see basically what the algorithm will give. Here, the point that we are trying to make here is the data that we will give, or the biases that we have, if the data has that biases, the system will also have those biases. So it is important that we are aware of it. We ensure that the data that we are giving is fair. The data should not in any way reflect those biases ahead, right? Because now what you see is systems are getting trained on data, then systems are getting trained on those systems, so that bias continues, right? So this is one important aspect of AI systems, and therefore you should always have a trial of the AI system before you plan to deploy it somewhere, right? This is a very good example actually. For a fair selection of everybody, everybody has to take the same exam, right? But what is the exam? Please climb the tree. So again, what you are looking at is, it's not fair for an elephant to have that exam, but just because of that you want the same exam for everyone, should it be that way? I mean, just a thought to have in the mind. Next is called robustness. So what robustness says is, so if you have an image, you have trained your system with an image, is there a way I can introduce some noise and I can get the system to give a completely opposite output? For example, this is a stop sign. Suppose I introduce some noise and now my system, though it looks like a stop sign, it recognizes it as a go sign. I mean, these are the new type of cyber attacks that are being tried with AI systems now. How you can just introduce some noise and probably try to get the system to give a completely different output. So you have to check for robustness of the AI systems. And to another level, AI is taking different possibilities. Now, I can actually show you one platform. So I uploaded my image here, okay. This platform is called DID. So what this is an AI based tool, and you can take any of these people, type your text and make them speak that. So I introduced, so it's not a very refined output that comes from here. Right? So what you can do is type your script or upload a audio. Now if I do a type your script, definitely the voice will not match my voice, right? But for that, I have something called Descript. What Descript does is, if you give it text, it will convert it into speech. And interestingly, you can train it to speak in your own voice. I have not spoken this text anywhere. Tinkering is a process of making small adjustments to an object or system in order to improve its jiva or performance. It's not very perfect. Yes. It's called Descript. And now what I can do is, I can actually record I can have my video, take the audio out, put it in this tool, change words and take it back. So now I can take this audio, put it here, okay, I tried to download a video, I don't know where it is, but yeah. Basically you can, that way you can create an avatar. But again, so if you go to this website DID,
tinkering is a process of making small
but
adjustments
here obviously the voice is a
to
mismatch.
system in order.
The voice is a mismatch here, but I can always upload my audio and make it do that, right? So now I'm trying to get to the website called DID. There is something, they have a page called ethics. So here every AI system will have a page called ethics, and they will talk about what they are doing, what they are ensuring so that this does not happen. Like I cannot create my avatar until I have signed in using an account. I mean, that's a very basic thing, but they have taken care of it, right? So the idea is that there have to be systems in place so that this does not happen. Even for Descript, I have to have an account, and they will take a voice sample of my live voice sample, compare it with the voice sample that I am giving, and then only create my avatar, create my voice. Yes. One, I am not the right person to answer that first, but there are ways to identify it. But again, these platforms are not that advanced yet that, I mean, even you saw that, even the face movement is not what natural face movement is. So an expert who is expert at say face expressions and all of those, micro expressions and all that, will be able to identify this is an AI generated thing, right? So it's possible, and there have to be checks to ensure that this does not happen. Like I was telling you, like Descript, if you want your own voice to be created by Descript, you have to record your own live speech. They will compare those and then only create your voice. So it's you who is actually creating your voice. Okay, let's come to the next point. Next point is called explainability. Okay, I agree, this is a very interesting thing, and even we are trying to see how we can use it actually in EdTech. Not just the scary part of it, but the good part of it. Like if you have to create MOOCs, how can you use these? So that is another thing that we are trying out. But let's come to explainability. What does explainability say is, okay, let's read this scenario first. So what explainability says is that it should be explainable why AI is doing something. Most of the AI algorithms are a black box. We don't know why is it doing it. But if you are taking an AI product and putting it in, say, deploying it in real life scenarios, there has to be explainability of why is it doing it. So that is another thing that is considered as one of the parameters of ethics with AI, right? So for that, there are regulations, national level regulations that make sure that whenever you are deploying an AI based product, you have explainability built into it. I mean, you know why if it is doing this, why is it doing this? And a lot of AI products have actually, so for example, how many of you have How many of you have done artificial image creation using, sorry? Delhi is one, Midjourney is other, right? So there also there are certain keywords which are not allowed. They have banned those keywords. So until unless if you use those keywords, it won't generate an image. That is their policy. So that policy is governed by certain things like explainability, right? And the last, but one of the most important one is privacy. Now we have a lot of things we are building into our systems to ensure that privacy is there, right? We are doing anonymization, we are using complex algorithms to anonymize data and all of that. But then when you have a lot of data of, say, that anonymized data of me, you can again use AI to de-anonymize it by data mining, by finding out patterns, and then creating an inference. Because earlier it was not possible for algorithms to crack such complex codes, but now they don't need to do it. What they can do is they can try to search for patterns, and all they have to do is associate that, say you are anonymized in some database as a hash, okay? But they can associate that hash with certain behavior patterns, and whenever they see this hash, they can always come back and give you some recommendations. So is it still anonymized? So you have to ensure that when you are storing data, or if your algorithm is working with data, it is not actually working towards de-anonymization of privacy. So these are the 4 major things that are talked about when we talk of ethics in AI. Okay? So, open discussion. So after this discussion, we'll be breaking for lunch, I guess. So answer based on what your experiences are. So there is a reason there is a counter and it's not showing the answers. I want everybody to give their own perspectives before I reveal it to everyone. So once we are to at least 20 answers, I'll okay, privacy is one of the most major bias, cost, validity and reliability of information. So interesting, validity and reliability of information shared via AI system. You have faced it with ChatGPT? Have you? Okay, anyone can share any context, like what happened? Like I have a very good example that I have. So, okay, I'll share my example. So we were working on a literature review of something, and we wanted to ensure, okay, have we forgotten or missed something? Just for the sake of it, we wrote it to ChatGPT, and ChatGPT gave us a number of articles, and we were surprised because some of them we had never seen. So we asked it for details of the articles. It gave us entire abstracts, DOIs. DOI is basically a number that is given to each and every paper, right? And when you search the DOI, it's a completely random paper. It's a very different paper. And the argumentation given by ChatGPT is very, very well written. And you will almost believe that this. So when we ask that we cannot find this research articles, so ChatGPT replies saying that probably the authors haven't published it yet. Bias, fake news, deepfake of politics, yes. Interesting, plagiarism. So this also comes from ChatGPT, I guess. So what is the concern? Like what is that you feel is the issue with the plagiarism wala part with AI? I mean, is AI plagiarizing or what is happening? Sorry?
Like, if they are asking kind of giving a task of give your thoughts on certain topics or certain this thing, and they get the answer from ChatGPT. Like now, if it is an individual class, 4 to 5% may end up with the same thought if they are using
ChatGPT, right. So one interesting way of we realized to do is to make ChatGPT the learner and you become the teacher, and then you start asking questions to ChatGPT. So then ChatGPT is teaching you and in turn you are learning. So if you do that, if you take this approach of Socratic questioning with ChatGPT, it becomes a nice learning activity for a student. So basically, so that's what I'm trying to get to is there are good sides and bad sides to all these AI based applications. It's just that we have to figure out how we can use it. Yeah, that's a very relevant challenge of plagiarism that we have now, right? Okay, so anybody else wants to discuss about any or share anything regarding their experiences? And we were doing that. Anything you want to discuss? So what is the takeaway? It is important to sensitize learners about these 4 aspects that we talked about. It is important to talk about ethics matrix is just one example of you trying to realize who are the stakeholders, what they are doing, what data they are collecting. And it is important to accept that there are some challenges, there have been some biases the way we have been. So there is a very good possibility they will get transferred when we build AI systems. So but the most important things, especially for learners who are getting into AI, is to have this dialogue about, okay, what is the boundary of an AI based system? Because in the future, these are the people who are going to build those AI systems. So that thought process has to start, that dialogue has to start, that what is ethical, what are the boundaries, and what are the things that they should, steer clear of, right? This we will do after lunch, and yeah, I guess 1 o'clock is the lunch, right? Yes.